waiting for my screen to tell me that I'm live. Anyway, we've got the new coils on, and I've been tuning it today, and then I realised a slight mistake because of the configuration, because I've got the ferrite cores half in on, well, if you look underneath, if I can get the flipping torch, I can't really see very well. I've stuck this paintbrush in so I could get underneath a bit so I can show you, but there's a ferrite core that's half sticking out of my magnet, concentric magnet assembly. Because of that, I realised that I had an air gap in the new coils, so I'm going to have to redo some more coils actually, and I'll tell you why in a minute. Because I've got a slight air gap. I've got an air gap in there. It was a bit of an oversight, but the good news is that it's working a lot better. I'm currently driving it at let's see, 35.5 volts on the high side, and we're drawing 50 milliamps at a pulse of well, you can see it on your see for yourself. The pulse width is the blue, but it's buffered by a capacitor. And the output is the yellow waveform. The input is, that's the pulse, by the way, is only half because I'm only measuring half of the input. The other pulses will be in the middle right there. There will be other blue on the blue trace. There will be pulses in the middle there as well, but I've only got one probe on the half bridge at the moment, so I can only actually see half the pulses. So, but there's actually two of those. Anyway, on the low side, we're still at the 30 minus the 50 milliamps that we used to drive the circuit board. So we're actually a lot better. We're actually consuming a lot less power. Well, I'll just turn that off a minute. So if I press this button down there, that's the quiescent current of the circuit. So it's using about 60 milliamps, 50 milliamps on the quiescent current side. Turn that back on again. You know, that's just this circuit down here that's using no, sorry, this box down here that's using that. So right, at the moment our voltage on the output is at 11.5 volts on the supercapacitors. Well, it's actually a bit higher than that, so they're ready to be discharged, but the actual output current is 56 milliamps, and that's pretty good, because if you remember, I think it was around 30 milliamps normally when we were up at about 12 volts. It was but all my supercapacitors are at 11.8 volts. I'm going to trigger that now actually, if I can. Oh, it's not tripped. Flipping thing. I need to trying to get these magnets because the relay is not clicked over. Just a minute. Trying to do this without dropping my phone. What are you doing? What have I done? Stupid phone. Oh, press that. I'm gonna log out on that, silly me. What the hell? What am I doing? Right, okay, that should discharge now. I won't press the button. I hate these phones. You put your finger in the wrong place and you go and put the phone to sleep. Right, I'm flipping. Oh no, what's happened? My computer's crashed. Why is my computer crashed? Flipping virtual machines just crashed on me. Flipping heck! You bugger! Right. Flipping virtual machine. I'm going to have to probably restart that now. Yeah, hopefully I'm still alive anyway. So, when that supercapacitor is discharged up there, we will see this voltage at this end start to drop, because I've got this configured slightly differently now so that we can actually measure current on that meter, the white one, that's going into the supercapacitors that are down here and down here. So I've got two lots of supercapacitors which are sending the power into, so that current will start to climb slowly. It's a better configuration that way, because it means that I can monitor the current in a linear fashion, because as you can see it's starting to climb slowly. Look, on the white meter it's going up to 58.9 as the supercapacitors discharge to the supercapacitors that are right up there. Right, when the power displaces across to the others, we'll start to see the current on the output increase on this end, at this down here, instead of it surging and overloading my meter and going over range and everything. So as you can see, the voltage is slowly dropping at this end, because as the supercapacitors at the bottom end down here, down there, as they discharge, this voltage is measuring AC. So it's actually measuring AC on one of these output coils here, right? So we get a good idea of what's going on. And as you can see, the actual current on the output is going up now. It's 66. I hope my virtual machine doesn't got trashed. I'll have to go and check that in a minute. So I've got a poor connection. I don't know what's going on with this thing. So anyway, the good news is the coils work pretty well, but I'm still not happy with it, as you can imagine. I mean, it's all about tweaking and improving. We're still running at about 2.45 kilohertz, as I was showing you earlier. I mean, you could probably see that. We're at 2.45 kilohertz. Peak to peak 26 volts. Cyclic RMS 10.4, but that's because of the load. So we're almost at 70 milliamps now. The supercapacitors are dropping at this end, at the bottom end, so we can expect that current to go up a bit more. If they were completely flat, we would be at around 100 milliamps. Now this generator, or power converter, I like to call it, has some very interesting anomalies, because when I short out with my knife, with my little paper knife, when I short out this coil, the actual AC goes up on the other coil. Tap the short off. Oh, actually it's going down right now, but when I short out one of the coils like that, the other coil is still pushing power out. Right? Normally, what happens is, when there's not much load, what happens is when you short out the coils at the top end here, the coils at the bottom actually produce more power, which is really interesting how that works. So we end up getting more power coming out the bottom coil. So I'm trying to work out now which one. These two, if I short out this coil here, this oscilloscope is connected to this coil here. We should see an increase on the waveform. So let me just let me find a jumper lead. I'll get a green one. So if I because the current's pretty small really, I'll put this jumper lead on. I've also done it with a resistor. It doesn't make any difference. Right, I've got a resistor here, look, because some people say we need to use real power. This is actually 8.1 ohm resistor. If I can get it to focus. focus very well. Come on. It's hard to see the grey because it's actually on the at the top end here. The grey band is very hard to see. You can probably see that now. 8.2 actually. It's 8.2 ohms, this resistor. So if I connect it to one end of this, I connect it to this clip like this, without it coming off, and if I short that out, when I short this out, when I touch that on there, right, I'm just going to hold it on, get on there. There's a light, there's a shadow in the way, it's hard to see. Right, I've got it on now. Look at my waveform on the oscilloscope. It hasn't dropped hardly at all.
Batch completed successfully.
Hang on a minute, take it off. Sorry, that's my automated script running on the computer. Right, so it didn't make any difference at all when I shorted it out. Let's put it on again. Now watch the meter though, right, the meter, when I short it out. Right, look, the meter, look, it's dropped right down, look. Right, it's dropped down to point, oh, the resistor's coming off. Get on. Right, stay on. Sliding about. Right, look at my meter, it's gone down to 0. Right, 0.05. But my other waveform output is still there. It hasn't changed. 22.8 volts. Look at that. No change. And the input, yep, the input voltage. Look at this one. Take it. Right, it's still on, right? Right. Brush is in the way. Take it off. No change. Look at that. No change at all. So it doesn't make any difference if I have this resistor on or not. So what I'll do is, if I bypass it directly, right? I'm going to bypass it directly across that. Now look. Now look. 4.05. Look at the waveform. Peak to peak. 22.8. Take it off. 22.8. Hasn't changed. That's we're shorting out that coil there, which is very interesting. So what I've noticed, oh look at that, our output is now at 73.1 milliamps. Well, we're going up. Now the other interesting thing is when I short this out completely, when I put this across here, our input drops right down. Our input current drops down to 20 milliamps on the high side. 20. Take it off. Put it back on. Back it out a bit so you can see both. Put it on. Drops to 20 milliamps. Take it off. So when I'm under load, I use less power, which is really cool. Anyway, what I've done is I've printed out these new bobbin halves. Now they're actually a bit bigger, so I've made up for the fact that there's an air gap, so I can get all my 3 cores in there. I'm actually going to have to wind some more coils. I'm not looking forward to that. Really dread winding more coils, but I was thinking about this earlier because there seems to be a slight mismatch somewhere. I don't even know if I'm still alive, you know. Is my virtual machine going to be alright? I'm going to have to check it out and make sure it hasn't got destroyed by that crash. Well, that got messed up. I'll have to put that back on automatic. my Ubuntu is not showing up because it crashed on me. I'm hoping it's not going to be all broken because I can't afford to get another one. Well, I'm just gonna see if that's still okay because it got reset. Fingers crossed it'll be alright. So while that's booting again, I'll just talk a little bit. What I've been working out is when I'm tuning this frequency, I can actually get it to dip on the input current to virtually nothing, but I do lose output current when that happens. And I have a suspicion that these coils need to be more on the input side. I think I need to have more coils on the input to bring that resonant frequency lower so that it matches my output stages, because the concentrics tend to be working on the higher frequency more so than the output stage. So I need to bring the resonant frequencies more into alignment, so that when I peak this, when I adjust my frequency and I get my dip on the input current, that the dip actually my input current drops. Oh, I can't do that right now actually, but you can see my output current, but my actual input current's gone up now. Look over there, you can see it on the meter probably. We're up at 110 milliamps. Look, and I have to get this dip in the right place. Oh, we're down at 40 milliamps now. That's good. We're at 71 milliamps on the output. So yeah, I have to I need to get this tuned a bit better. So, oh, my virtual machine survived. Thank God for that. Oh, it didn't get messed up. I have to use it because I'm on XP, you see, and the problem with XP is that certain websites don't work anymore. You know, when you try to go on certain so some of the scripts are newer scripts and they don't work, and I've got to go on here when I want to log on to some websites or create accounts and things like that. I had that problem recently. So for example, Discord won't work on my computer anymore on XP, so I have to have Discord on here, which is really annoying. I've got it on my phone, but when I want to share files from the computer, it's a real pain trying to copy files off the computer onto the phone. Oh, it's such a nightmare. I mean, there's no easy way of dragging. You can't just drag files across. You can't just drag a picture, schematic diagrams and things like that. You just can't drag them over because you've got to get special apps to do that, and it's a real pain in the ass to do that. So what I've been doing is, oh damn it, I hate it when it does this. Password key lock, whatever that is, I don't know. I don't know what that key lock's all about, but you've got to log in, otherwise you can't get your browser to work. Anyway, so back to my diagram, my circuit. So I'm making progress. I've got all my... Oh, they're a lot quieter, by the way. That rubber, amalgamated rubber that I used on the... as you can see, the black stuff that's on the coils, it's reducing the noise at like 60%. So there's actually 60% less noise. Oh my god, it hasn't remembered my pages. Oh, it says here restore. Ah, thank god for that. Ah, yeah, I can restore my pages. Yeah, I was thinking I haven't bookmarked them. You see, I just basically pause the virtual machine when I'm not using it, and I just have to unpause it and resume where I left off. And oh, thank God the stream's still live. Ah, it says there. Yay, it's still running. Yay. I thought I'd lost it. I thought I'd lost my stream for a minute. So, kind of busy. I hate it when it keeps using the previous title for the next stream, which is really stupid. I don't know why it's doing that, but it's using the same title that I made for the previous live stream on this one. Ah, silly thing. I don't know. Well, anyway, YouTube has really messed up things up lately. So output current 71.2 milliamps, and we're at 8.17 volts. That's pretty good, really. That's considerably better than what it used to be, I think. Considering that I'm at the 200 milliamp on the low side right now. So we're at 40 milliamps. About 40 milliamps on the high side. Well, that's pulsed at 35.52 volts. So yeah, what I'm going to do is I'm going to put these new bobbins together. See if I can get them off the print bed. So what I have to do is I have to join them together. So oops, there's one half. The other half. So what I have to do is stick them together with acetone, clean them up a bit, obviously. So they'll basically be this long. If I can get it in, if I can pick both of them up, right? So they're going to be a bit longer, but I'm going to use 25 SWG wire. I'm going to clean them up because so yeah. Anyway, so I'm going to be doing some more bobbins. My whole life seems to be all about bobbins these days, but yeah. So I've got this resistor again. Now if I put this resistor across the other coils, let's put it across this one. My input current's just dropped to 20 milliamps and my yellow waveform disappeared. Oops, I'm not connected properly, but yeah, it definitely is doing some interesting things. As far as the rotary system, well, I've kind of abandoned that because this thing's got more promise and more purpose. But I mean, if people want to see the rotary system go, just click on my videos and go and look at the old videos I was doing tests with it, because it saves me having to redo all that again. But I've got old videos on it. I haven't even made a playlist. I need to do a playlist sometime, I suppose. But I just wanted to give you an update on the new coils, and yes, they are definitely better. I have actually got them configured in an unusual way at the moment. I have two capacitors in series with these coils, these two coils at this end, but these two coils I've got wired direct. Why did I do that? Because I found I get much more output. Don't ask me why that is, but it's all to do with the delay and how long it takes for the flux pulses to get from this side through these cores all the way around to this side. Well, I've been experimenting with phase shifting using some capacitors in on this coil, on these two coils on this side. So when I put these two 330 nanofarad capacitors in, it seems to it seems to work better, but my input current is quite high. But when I wire it so they're all direct, my input current is very low. It actually drops right off to, I've actually had it down to as little as 50 milliamps, but my output current was down to about 30, which was really pathetic, and that was worse than it was before. So that's the reason why I've got these two capacitors in right now. That's what's telling me that I possibly do need to make some bigger coils, longer coils, and match them at about the same impedance, between 2 ohms each coil and about, well, 3.5 ohms, because the original coils that were in there were mismatched, if you remember. Coils back in and try them again with these new cores that I put in, because I have put new cores to couple the magnetism to the inner core, ferrite core. So that's another reason why it popped up. You can see the steel part down there between that gap, and I've lifted it up a bit because I've got extra ferrite rings in there right now, but these coils need to be a little bit wider. That's why I printed these new bobbins. They're going to be a fraction longer, about, well, actually 4 millimeters higher. So I might wind, I'll probably be winding more turns on there, with the option of removing some if I need to do. It's probably better to put extra turns on, with the ability to literally take a whole layer off. It's easier to take a layer off than it is to prat about winding another layer on, adding it later, because once you cut the wire, you have to solder the wire onto it, then you have a big lump of metal, of copper, that sticks out, and it's a bit of a mess. So I thought, well, what I'll do is I'll wind some longer bobbins, probably go up to something like 200 turns, or even 250 turns, if it's going to be a longer bobbin. So and I'm going to use the rubber again, amalgamated rubber, to reduce the noise, because if you notice, I don't know if you can hear it, but it's actually pretty quiet. Can hardly hear it at all. 8.33. Yeah, it's going back up again. So we're actually starting to climb again on the output voltage. What else was I gonna cover? Yeah, the previous coils I wound were actually a bit narrower, but they didn't work as well. They were pretty crude. They didn't work so well. They were actually a bit narrower, but they didn't work so well. These longer coils seem to work better. So what? Because if I use the same 25 SWG wire and make the coils longer, then my impedance is going to go up, probably too high. So I have to decide on what I'm going to do there. I've still got quite a bit of 22 SWG wire which I can use if I decide to do that, but yeah, anyway, I thought I'd let you know what's going on. There's definitely an improvement. As you can see, I'm only at 50 milliamps on the input on the high side, which is, I think it was, I can't remember now exactly what it was before. I think it was 70 or 80 milliamps or something. It was definitely higher than what it is now. So every time I've made an improvement to my coils, every time except when I put those on, that is, and the really big long high impedance 15 ohms coils I put on, they were way too high in impedance. So 15 ohm was just terrible. But those coils were lower impedance. I think they were like 1 ohm or something, or was it one? Yeah, it was about 1 ohm each, I think. I could measure it, but I've got the phone in my hand, it's difficult. Yeah, the really low impedance coils are no good. The really high impedance coils are no good. it has to be tuned at this frequency at 2.5 kilohertz, where it seems to work better. And it's just a question of getting these coils long enough as well, because they have to be a bit longer to enable more saturation of the core material to actually take longer to rise and longer to dissipate. The core material, and it jumps across to the other side, meets up with and collides with the other side, which gives you the current. When I disconnect one half of these, if I disconnect two of them coils, my output just drops off to virtually zero. It just disappears. It's gone. Like, I could show you that actually. If I disconnect this lead from this capacitor that's in series, if I take this off now, there's my current. It's just dropped down to 41 milliamps. Put it back on. It's gone back up. It's going back up. Yeah. So yeah, I lose a lot of power when I take, but my input current drops off anyway. My input current has dropped to 30. It's not tuned for that though, so I'd have to retune it just for one pair of coils, you see. But anyway, I'm waffling a bit. I can't think of anything else to update you on, but it looks like it's going to be another boring day of 7 or 8 hours of coil winding, because my stuff arrived today for the, I use this pipe stuff. It's actually for using on pipe threads, but it's perfect for separating the layers of the coil. I might be able to use that, but if I'm making a wider bobbin though, it's going to be a problem because I haven't got any tape wide enough to, so I'll probably have to stagger it or something, which I hate doing. I usually use a knife and cut it so I can get the right width of tape for the bobbin when I'm wrapping each layer, otherwise it's uneven. So I'll probably have to do that again, unless this will. No, I can't use that. That's my thermal tape. I want the coil to keep cool, so that will just make it get hotter because it won't have any cooling. Yeah. So anyway, we're having positive results. I've been waffling for God knows how long. It's what's really weird. My phone says poor connection, right? But on Livestream Studio it says excellent or something. What was it? It said something a bit ago. It said, what was it? According to that, it's doing well. Is that people are viewing? I don't know. Somebody called John Smith again. I don't know who that is. You won't tell me. John Smith. I don't know who that is. Yeah. Well, it's a free energy device, or hopefully free energy research, but obviously we're not there yet. Magnetism that's in the rings, and extract that magnetism and then shape the magnetic field from the static magnets into usable energy, which is not easy to do. It's all about getting the right frequency. I mean, if I detune this thing, if I detune it slightly, right, I don't know if you can hear the frequency, but if I detune it, watch the output current. My output current's completely gone to shite. Go back up. Yeah, disappeared completely. It disappears completely at 3.47 kilohertz. I want to be at about 2. Also, when you detune it, my input current shoots right up, look. Yeah, that's when it's detuned, my input current goes right up. I'm going to tune it again now. That's about it. Yeah. So, what do you mean I do know you? CB radio. I don't know. Amateur radio? Or CB radio? I'm just reading what this guy's posting on here. I don't know. I don't know you. Well, I mean, using a name that's generic. I mean, there must be a billion John Smiths in the world. Maybe you should give me your CB handle, then I might recognise it. I mean, you can't give anything away by giving me a CB handle, can you? It's not even your name, it's just a handle. Besides that, I don't think comments are available after the live stream ends, so nobody else will be able to read it. So, because the comments are, I think on my live streams are disabled once the stream ends. Unless I don't know you from CB radio days, or maybe you're a neighbour now, but SD47 and Skyrider. Oh, I don't know what SD47 is, but Skyrider rings a bell. You don't live in Scarborough, do you? SD47 doesn't ring a bell at all. I have no idea what that means. I was searching the internet the other day looking for SD47 because I thought it was an emotion, a smiley or something. Yeah. Oh yeah, that's right. Yeah, I used to fix CBs. Yeah, that's right. Yeah, yeah, but yeah, I used to fix CB radios years ago. Yeah, but the Chinese put an end to all of that. All the repair industry disappeared as soon as the Chinese started releasing all their cheap stuff, cheap junk. And the only people that actually bothered to get stuff repaired were people that were wise enough to realise that this cheap stuff wouldn't last 5 minutes, and they had Amstrad junk breaks every 5 minutes, and this Sierra Delta Club. Right. Well, anyway, to go back to my project, I don't want to distract too much, but it's extremely advanced, this stuff that I'm making. I mean, there's only one or two other people on the internet who have worked on something similar. There's a guy who worked on the MEG, the motionless electromagnetic generator, which is very similar very similar to my device, but my device uses both poles. It's dual pole. Let me just see. I think I've got a picture around here somewhere. I think I've got a picture on here somewhere under this lot. If I can find it. I don't know where it is. You know what's probably happened? I've probably spilled coffee on it. It's probably going to end up in the bin. Where is it? No, it's gone. Yeah, you can look it up on the internet, but there's John Bearden, I think his name was, who created a device called the motionless electromagnetic generator. But well, mine is actually a power converter. It's a transformer, but it's a power converter. I don't like to use the same names as other people because I'm not using their technology. I'm using my own technology that I've been working on for like 3 or 4 years now. It's my own research, and it was kind of a collision when somebody actually... It was a collision when somebody... Oh, it might be over there. I'll just have to move that lot out of the way. I tend to chuck a lot of diagrams. I need to sort this lot out. Huh. Yeah, it's definitely had... I probably spilt something on it, and it's ended up in the bin. But I've got diagrams all over the place. Yeah, this is my rotary system I was working on. This is what you've seen over there, basically the rotary system, but I designed. But that kind of had too many hiccups with it. And this is my... Oh, I've forgotten now. Yeah, I've got all these circuits I drew up myself. I can't find the Meg. I don't know where that's gone. But don't matter, you can find it online anyway. So, oh my God, you have been busy talking. Yeah, you're talking about the DNT rig. I've got a surprise for you. Good buddy, I have a surprise for you. I still have it. But if you look at the knobs, you'll notice all that dust. It's never used anymore. It's just an ornament now. I still have it, yeah. It's the same one. Does it work? You're gonna ask me next. Does it work? Where's the lead for it? Where's the plug? Where's the lead? Oh, where are you? There's no aerial on it. Why am I diverted into this? Oh, I can see the plug. Look at the state of the plug. Got all that crap on it. It's been sat here, but I've still got the mic as well. I just haven't used it. See if I can get the mic. See if I can get the plug out. Look at all that crap down there. I need to dust. I can't find the end of it. I can't find the plug's so tangled up. I can't get it out. Now I've got it out. Oh, you're lucky. Look at the crap on here. That's how busy I am. I can't even be asked to dust my own old DNT radio. Right. Find a plug for it. Ouch. Have I got a spare socket? That is the question. Do you think it'll blow up? Do you think it'll blow up? It doesn't want to come on. Probably dirty connection or something. Yeah, it won't come on, look. It's an ornament. It's probably the plug that's I'll tell you what, I'll leave it switched on and I'll wiggle the plug about. I think the plug's got dirty on it. It's been it won't work. It's dead. Let me try a different hole. My robot vacuum works. I put that in a different hole. Oh, look at that. It's lit up. Look at that. There's no antenna in it. Hang on. I can stick this in the hole. There we go, we've got an antenna. Stuck that in the hole in my meter. Now we've got an antenna, look. Nobody on. Well, it still works. Yeah. But no, I don't use CB anymore. As you can probably see, there's no aerial. I just stuck this piece of welding rod in the end. Just to I have it here for one reason. I took it out of the cupboard because I was curious to see if it still worked, that's all. And it kind of got stuck here, parked here. Now it's just collecting dust, literally. And I just listen on it. I don't talk on it anymore. Yeah, it's a ghost channel now, just the ghosts. What was it, last year? I can't remember now, 2 years ago. I put a date on it somewhere. Hang on. when did I make it? Because I lose track now. I'm getting too old. I'm 61 now. So there's where I made it. I always put dates and everything that I make. May 2018 is when I built that. Revision 12H. I just put a random thing on it. And if you look at it, see, it says designed by Autoria. I put my handle on it. It was designed to flip all Nico magnets when I built this, but it'll drive any AC circuit within reason. Well, as long as it's too big a current on it, that is. Uses opto-isolators to decouple to prevent EMF from backtracking up the line and interfering with everything. But I'm going to have to end this stream in a minute because my battery on my phone is at 59%. It's a lot better than it used to be though, because I got a new battery for the phone, and well, research and development, R&D. So anyway, the next phase is to improve the drive coils again, which seems to be the only thing I seem to be improving right now. It's pointless changing my output coils because I've got different stages of output coils. I've got ones with small turns. That coil has got 30 SWG wire on it. There's a hell of a lot of turns on there. And I think the other one's 30 SWG as well, but it's fewer turns. So these coils are all staggered. Every one of these coils on the output stage are all staggered. That's got thick wire on it. That's got medium-sized wire on it. Well, actually no, I think it's the same gauge actually, but it's got more turns on there than that one. So these are all staggered, and the reason for staggering them is because in some situations I might have too much voltage, and in other situations not enough voltage. So I want one coil that's at least going to provide a useful voltage that I can use to drive some of my circuitry, or I might want more current, and so some of these coils can deliver more current. So that's the reason why I stagger the output coils because you never know what you're going to get when you're messing about with all the concentrics and the magnetic fields and everything. But I mean, you've got 3 years of videos to go back over if you want to look at all my old stuff. All you have to do is click on sort and sort by oldest first, and you'll actually get to see the older videos first, and you better go forward. There's something weird. You click on the video section on my channel and you start to scroll backwards in time, you can only seem to go back about 3 or 4 pages and then it just stops. But it doesn't do that if you click on sort order oldest first. If you click on sort oldest first, then you will actually see all of the videos. You'll be able to scroll back a lot further than what you can normally. I don't know what it is with YouTube, but YouTube seems to be broken. It's always broken. They just keep breaking more things all the time, and yeah. But oh, what have I done? What have I done? My output voltage has dropped to 4.19. Why is that? Just let me find out what I've done. I've got a short somewhere. Why has it dropped? It says 4.17. It can't be, because oh, maybe it wants to retune in again. I probably detuned it slightly. That's probably what I did. It's just, what am I at? I'm at I'm at 2 kilohertz. That's why I want to be at 2.5 kilohertz. um, yeah, that's what it is. Ah, there we go. Yeah, I was detuned. Right, so that voltage has gone back up now, and that current's gone back up again. We're still at 50 milliamps. Right. Oh, anyway, it's time to end the stream. I'm sorry what the chat will stop when the this all this circuitry has polyfuses in it. That's a polyfuse. That's a polyfuse. Oh, you were talking about the CV, weren't you? I think. Basically, a polyfuse is like a momentary switch which cuts the power off if you overload it, and it resets automatically. It gets hot, about 100 Celsius, about as hot as hot water, cuts the power off if there's a overload, and it resets and comes back on. A lot cheaper than buying fuses, I tell you, and putting them in. A lot cheaper. You'd have to keep buying the fuses all the time. CB radios, you should have had them in years ago. Then people wouldn't have been coming to me to get their CB radios fixed. Yeah. Anyway, the CB's still working. Just wants an antenna really, but I don't use it. I've got it there to listen on. Just to have I actually heard a taxi driver on there once a few years back. It was about, I think it was about 5 years ago. A guy came to Scarborough. He was down by the seafront, and I actually sold my Honda to him, which was kind of surprising. I actually got a sale out of it just by switching this thing on. I was able to sell my old moped, which I'd had for donkey's years, which I had when I was at Dean Road even. I actually sold my moped to, well, 50cc, to a guy who was visiting our town. Saved me an advertisement. So it was worth getting out of the box, the cupboard. This was in the cupboard, and it worked for a while. I heard this guy shouting, "Night in a Roger, night in a Roger," and I actually hooked up an antenna just so I could talk to him. Electromotive force. Well, it's basically magnetic field harvesting. It's when you harvest a strong magnetic energy and shape it into usable energy. And these are my concentric sixes. They're actually alternating fields. Each alternate pole. This is similar. This is just the same as what's in there, really. So those have got my magnets in now, and when you bias them, you can actually see the magnetic flux change. I suppose I could show you quickly if I get my viewing film. Just a minute. I'll get my viewing film on it. So put my viewing film on the concentric 6. It's actually inside the bag. I don't know if you won't be able to see it very well inside the bag. You can see it there. Look, you can see like lines. Now if I was to bias it, I'm going to have to put this on the table. Now look at that. Isn't that pretty? I'm going to put the magnet under the table. Now watch. Stick. Now, oops. Right, when I flip the field around, oh, this is not working. I need to bring it closer. Hang on a minute. This is difficult to do with one hand, because I am using one hand, by the way. What I'm going to do is I'm going to put the magnets on. well, I was going to put the magnets on a pair of pliers, but the pair of pliers decided to go to the magnets. Hang on. Right. I've got a lot of magnets on here, but simply because I don't have to go so close. I'll need to move this in a minute. Stick that stack of magnets, and I'm going to use this. I'm going to move this around instead. Oh, it should be easier. If you watch the magnetic field on there, you'll see it change. This is going to probably grab me in a minute. I'm going to put my finger there, so oops, viewing film is slipping about. Hang on. Right, if I can put my finger there without trapping my finger. Ah! I told you it would grab me. You can see the different shape in the field. You can see that 3 of the magnets are actually, by those little lines, are actually turned off, and the other 3 are actually turned on by that magnetic field. So they've actually switched poles. If I can pull this off without hurting myself. Oh shit, can't get it off now. Oops, I'm pulling the car out. Ouch, that didn't work. I had to tilt it. Yeah, it's a bit difficult, but the viewing film shows you a magnetic field, right, as you can see. I need to get a different. I'll get the C8. The C8 might be a bit easy to show you. This is the C8, it's a bit bigger. Right, I'm going to try and do this without hurting myself. Right, there's a C8, and you can see the fields that are off are actually the ones with the rings around them. The ones that are on are actually sending a pole down the other. Actually, they're not off, actually, they're on. But if I can lift this out without pulling the coil out the middle, you'll see. I've got videos dedicated to this. As I lift it up, you'll see it collapse. And oh, this is memory film, so it doesn't change until you reverse bias it. So I've got to reverse bias these magnets the other way around. Right. So this is basically electromagnetism does the same thing. So this should change shape as I get closer to it. If I can keep it from jumping at me. Probably happens so quick you'll have to scroll back and have a look. I'm going to pull the car out in a minute. But anyway, that's basically what the concentric magnets do. There's a lot of magnetism in them. They're alternated. So if I go on the outside, you'll see that that's attracting. That one's repelling. That's attracting. And that's repelling. Attract. Repel. Attract. Oops. And you get the idea. So that's basically what that does. It's switching. So this is a full wave device, whereas that other guy Tom Bearden did a half wave system. Yeah, it was Tom Bearden, that was it. Yeah. Alright, all CB radios go for an arm and a leg. Yeah, well, I'm kind of covering new ground with this stuff, you know, it's highly unexplored. Oh, not many people have explored it, so yeah, it gives me a headache. Anyway, I'm going to have to go. So this video has been going, this stream has been going. But it was wondering what. Yeah. So anyway, I'm going to pause the virtual machine now, because I want me to read your chat, by the way, Mr. Smith. I'm pausing the virtual machine. It's going to sleep now because I've got to end the stream anyway. So when my computer crashed earlier, I was panicking a bit. Right, so that's gone to sleep. Right. Yeah, for some reason there's no chat on this phone of mine. It doesn't actually show chat on here anymore. I don't know why. Anyway, thanks for watching.